continuing in 12.3. We're up to example 4, and they want us to consider the circle r equals 1 and the cardioid r equals 1 plus cosine theta. So let's see. Graph of a circle of radius 1. And then we need the cardioid. We're going to mark this as 1. And if you graph the cardioid on your graphing calculator, you will see that it goes all the way out to 2 when you plot points. And it's sideways. It comes like this, all the way around to 2. My pen is sticking. Back through that spot. And so they want us to find the area that is inside the circle and inside the cardioid. So we're looking for that lima bean shape in the middle. The piece we're looking for goes like this. Alright, so we need to know where they intersect. Well, the easiest way to do that is to set the two equations equal to each other. So 1 equals 1 plus cosine theta, which means cosine theta equals 0. And the question is, when is the cosine of theta equal to 0? And that would happen at, plus or minus pi over 2, which you actually can see these spots. That one's right there. This one's right there. And so my formula, we're going to look at this as two separate pieces here. The one piece is a semicircle. So if I'm looking at it again, let me draw it again. This piece right here is a semicircle of radius 1. So I could figure that out. The area of the semicircle is 1/2 pi times r squared. So it's pi over 2. So now what I'm trying to look for is the two crescent shapes. These two pieces here. So I'm only going to look at the top one. And if you're looking at the original graph, you will notice that the top one is happening between pi over 2 and pi. If you graphed it by hand, you would find those are the intersection points. So I need to integrate from pi over 2 to pi, 1/2, the radius. Okay, now the radius in this case, that crescent shape is strictly being determined by the cardioid's equation. So it's going to be 1 plus the cosine of theta squared. Okay, so that turns into, let's pull the 1/2 out. And what I'm going to do is I'm going to get this answer and I'm going to double it, because I'm only doing one crescent shape. And that's going to be 1 plus 2 cosine theta plus cosine squared of theta, which I now need to use the half angle formula on. So it then turns into 1 plus 2 cosine theta plus 1 plus cosine 2 theta over 2. And I would split that. I don't want to rewrite it, but I'm going to write over here. That little piece is going to turn into 1/2 plus 1/2 the cosine of 2 theta. So I have 1/2, integrating 1, you get theta. Integrating cosine, you get sine. And there's a 2 in front of it. Integrating 1/2, you get a theta over 2. And integrating cosine of 2 theta, you're going to get a 1/2, and then there's going to be a 1/2 there, and then the cosine of 2 theta's integral is 1/2 sine of 2 theta. So I'm going to end up with 1/4 sine of 2 theta. Oh, not 0. Pi over 2 to pi. And so now I have to plug and chug my way through. That's going to give me pi plus sine of pi is 0, plus pi over 2, sine of 2 pi is 0, minus pi over 2, plus the sine of pi over 2 is 1, so 2, plus this would be pi over 4, and this would be the sine. 2 times pi over 2 is pi, that would be 0. Okay, so I'm going to have the pi over 2's canceling. I'm going to end up with 1/2. My pi and my negative pi over 4 is going to be, not plus, parentheses, 3 pi over 4, and then minus 2. Distributing the half, I get 3 pi over 8 plus, not plus, minus 1. That's one crescent. I need to take that answer times by 2 to get both pieces, and I need to add to it the pi over 2 for the half circle that we did at the very beginning. So I end up with 3 pi over 4 minus 2 plus pi over 2. That would be 2 pi over 4. So 5 pi over 4 minus 2 for the area. And that was part A. Part B wants us to find the area of the region inside the circle but outside the cardioid. So let me draw this again. Inside the circle but outside the cardioid. And I've got to draw another cardioid now. It goes out to 2. And that's 1. So inside the circle but outside the cardioid is the shaded region I have left here. Now, we could do this two different ways. We could look at this and say, all right, remember when you look at a polar graph, you're looking at it sweeping an angle. And you're looking at it this way, which means this curve would be the outside curve, and anything inside it would be the inside curve. And I don't want to draw on it because it's going to all show up at the same time. So if I look at my crescent, it appears that the circle is on the outside and the cardioid is on the inside. And again, it's the same. If I do just the top half, still be using pi over 2 to pi. So I'm going to double my answer. So 2 of these from pi over 2 to pi. Then I have my half, and then I have my outside radius is the circle squared minus my inside radius. Oops. Oh, I forgot the theta. Okay, how am I going to fix this? Okay, theta and then squared. D theta. And if I multiply that mess out, what did I write here? And the book has left out a lot of steps here. I'm going to pull that half to the outside, so it's just pi over 2 to pi. 1 minus 1 squared is 1 minus 2 cosine of theta minus cosine squared of theta. The 1's cancel. And so I have a negative 2 cosine theta and, oh, see, the book just went to the answer. Shame on them. This next piece is going to be minus 1 plus cosine 2 theta over 2 d theta. If we integrate this, let's see what we get. We get negative 2 sine theta, negative 1/2 theta, and negative 1/4 sine of 2 theta. And so now we're going to plug and chug. The first one is 0. The second one is negative pi over 2. The third one is 0. Putting in pi over 2, I get negative 2 minus pi over 4, and that one's 0 as well. So I get 2 minus a pi over 4, and that's my area. Now, I didn't have to do all that. If you look at it, the first problem we did was the lima bean portion, and so the portion we're doing in part B is the rest of the circle. So the answer could just be the area of the circle of radius 1 is 1 pi, and subtract from it the answer we got in part A. This piece right here is the area equals pi times 1 squared, the whole circle. And so this will end up being 2 minus pi over 4. This would have been a much faster way of getting the same answer. But you've seen two polar graphs done now. That's the end of number 4.